Alright, given tangent of theta equals 3 and cosine is less than 0, find sine and cosine. Alright, so make sure on the big picture idea, we're not drawing triangles anymore. We're kind of solving them algebraically. So I need to think of something. I need to think of one of our fundamental identities, Pythagorean, quotient, and that's something that has both tangent and either sine or cosine in order to solve for the other trig functions. Well, I'm thinking to myself that there's a quotient identity. Quotient identity has tangent, sine, and cosine, but these are unknowns. So I can't solve a problem that has two unknowns. Does that make sense? Because two unknowns means you have to use systems of equations. So I'm thinking a form of cosine is secant. Well, there's an identity that has both tangent and secant in it. Put your finger on it. Partner A tell partner B. Javier, which identity has both tangent and secant in it? Raise your hand if you got that. Okay. So what I'm going to do is I'm just going to do my substitution now. Tangent equals 3. Now, remember, if you get confused, tangent squared theta is the same thing as tangent theta squared. You see that? It's just the power of 2 you're used to on exponents. They're on the top right as a postscript. But in trig functions, they're kind of in the middle. So that looks a little bit intimidating, so you can just write it like this. And then I'm going to do a substitution for tangent. I'm going to put in 3 there. Let's simplify together. Cos 3 squared.
9.
And then 9 plus 1 is 10. Cos, how do I get rid of the square root? How do I get rid of the power of 2? So we're going to take the square root of both sides. Now remember, when you take the square root of an equation, it's both plus or minus, yes? But this is where this comes into play. Cosine here basically means negative. Do you see this? Pay attention. This is a hint in which we can use, because I have here plus or minus the square root of 10. Now remember, secant is which two letters? And then I want cosine. So cosine is x over r. So I can just take the reciprocal of this. 1 radical 10. But remember, it's negative, so it's negative 1 over radical 10. And then here I'm just going to rationalize. And I'm going to get negative radical 10 over 10 for cosine. And that's my answer. Now, there's a couple of ways that you can solve for sine now. You can use the quotient identity. Tan equals sine over cosine, because tangent is equal to 3. Cosine is equal to negative radical 10 over 10, and then you're just going to solve for sine. You can do that. But I'm thinking ahead to myself and recognizing, you know what? I don't really want to deal with division, so I can use something else. Over here I used a Pythagorean identity. Look on your formula sheet. Do you see an identity that both has sine and cosine, but it's not the quotient identity? Partner B, tell partner A, what is it?
Sine squared plus cosine squared theta equals 1.
Angel, tell me the Pythagorean identity. Again, you can use the quotient identity, but I'm kind of going away from that because it has a, I'm going to have to deal with a fraction and a fraction. So sine, I'm just going to rewrite this, sine theta squared plus cosine theta squared equals 1. Here for cosine, I already have cosine. Cosine is negative radical 10 over 10. So I'm going to do a substitution right here. So I have sine theta squared plus negative radical 10 over 10 squared equals 1. So this is going to repeat itself. Class, remember this means you have two of these expressions. So what's a negative times a negative? Let's write it out. Maybe this might help you. You don't have to. Negative times negative is radical 10 times radical 10. Radical 100, which is 10. And then 10 times 10 is 100. And class, that reduces to what? 1 over 10, right? Now pay attention. I'm looking ahead. I recognize that I'm working with a denominator of 10. How do you make this a fraction? To get the lowest common denominator, I'm going to have to multiply 10 over 10. So this gives me 1 is equal to 10 over 10. And the reason why I do that is because I'm thinking ahead, right? I'll subtract 1/10. So I have sine theta squared equals 9 over 10. And then here, I'm going to take the square root. You have a fraction, square root of a fraction, so the square root of 9 is 3. The square root of 10, or really it's 1/10. So that's still in the radical. Do you see that? So I'm going to rationalize. I get sine of theta equals 3 radical 10 over 10. But here's a hard question. Because I took the square root, is sine positive or negative? Let's look back at our clues. Cosine is negative. All students take calculus. This is where it is positive. Therefore, I know that cosine is negative here and here. Do you guys see that? Now, it doesn't tell us. It doesn't tell us where. I know that sine here is positive, and I know that sine here is negative, and I'm not quite sure which one. You can do your triangles. Gives you an idea. So let's just say I'm in here. That means means you get a y value that's 3, x value that's 1. But I need the opposite over the hypotenuse. This would tell us positive. In this problem, it's negative. And the reason why it's negative, if we had used, if we use the quotient identity, think about it. Positive divided by a negative becomes what? I'm going to know that sign is going to be a negative because I need a negative divided by negative to be a positive. So if I use the quotient identity, I would have figured out it to be negative. Or if I drew out the triangles to double check my answer, I also knew it would have been negative. So here's two problems using the identities to solve for the sides of a triangle, but we're not drawing those out.